Welcome back, children. In the last class we have studied what is the meaning of increasing and decreasing functions. How to, using derivative, how to check whether the given function is increasing or decreasing. We can do more problems. So look at the first question. Show that the function is strictly increasing on R. Function is strictly increasing on R means f dash x derivative should be greater than 0. So we can check whether it is positive. So f of x is 3x plus 17. What is f dash x? What is the domain of the function? Domain is set of real numbers. Any real number you can give for this x. F dash x is derivative of 3x, that is 3, derivative of 17 is 0. This 3 is greater than 0. We can write it is greater than 0. So what is the conclusion? Therefore f is strictly increasing. F is strictly increasing on R. Now the second question. Show that the function f of x is e raised to 2x is strictly increasing on R. Here e raised to 2x exponential function. The domain of exponential function is any real numbers. You can give any real number. F dash x. So f of x is e raised to 2x. What is f dash x? E raised to 2x derivative is e raised to 2x itself. Then by using chain rule, what is the derivative of 2x? That is 2. So 2 e raised to 2x. Then range of this exponential function, it is always a positive real number. That is e raised to 2x, that cannot be negative. It is always positive real number. And this cannot be 0 also. When we give x is equal to 0, this part becomes 1. So anyway, this f dash x is greater than 0. It cannot be less than or equal to 0. So f is strictly increasing. Strictly increasing on R. Now the next one. Prove that logarithmic function is strictly increasing on 0 to infinity, open interval 0 to infinity. So let f of x is log x, that is logarithmic function. What is the derivative of f dash x? And this log x is defined only for positive numbers. Log 0 is not defined, it is not defined for negative numbers. That's why it is given 0 to infinity, open interval. What is the derivative of log x? It is 1 by x. And we can give x as these values, open interval 0 to infinity. So this quantity, that is always a positive quantity. F dash x is greater than 0 for each x belongs to which interval? Open interval 0 to infinity. Hence, f is strictly increasing. It is strictly increasing on 0 to infinity. Okay. The next one is prove that f of x is equal to x cube minus 3x square plus 3x minus 100 is increasing in R. Like a polynomial function, it is defined for every real numbers. So first we can find the derivative. 3x square minus 6x plus 3. Last term is a constant, its derivative is 0. Now from this we can take 3 outside. X square minus 2x plus 1, that's equal to 3 into x minus 1 whole square, isn't it? X minus 1 whole square, when we expand we get x square minus 2x plus 1. Now what about this quantity? Is it a positive number? Definitely positive number, x minus 1 whole square. The square means it is greater than or equal to 0. Can it be 0? Yes, when x takes the value 1, 1 minus 1 becomes 0. So this total quantity can be greater than or equal to 0. Understood this? It is greater than or equal to 0. Therefore, we can write f is not strictly increasing, it is increasing. If equal symbol comes, then it is increasing. Increasing for all real numbers, that is in R. Now the next type questions, we have to find the intervals in which the following functions are strictly increasing or strictly decreasing. We have to find the interval. So the method is, first we have to find the derivative, then put equal to 0. From that you will get the values of x. Then you can find the interval. So look here, f dash x is equal to 2x minus 4. Okay, or 2 is common, we can take out x minus 2. Maximum you simplify or write f dash x as product of factors, that is the technique. Now f dash x, put equal to 0, f dash x equal to 0. That implies 2 into x minus 2 equal to 0, which implies 2 cannot be 0. So what is 0? X minus 2 equal to 0, which implies x is equal to 2. What is the domain of the function? X square minus 4x plus 6, domain is R. So mark this 2 on the number line. Infinity minus infinity, 2 is a point. At 2 the function f dash x is equal to its derivative is 0. Now we mark 2 on this number line, so we get 2 disjoint subintervals. Which are the subintervals? Minus infinity 2 and 2 to infinity. Now we have to check whether this interval, in this interval function strictly increasing or decreasing, or in this interval it is decreasing or increasing. So you can draw one table here, interval, first column interval, then sign of f dash x, then third column nature of f, like this 3 columns. Then we have 2 intervals. Which are the intervals? Minus infinity 2. Then put open symbol. Here the question is strictly increasing or strictly decreasing. So for strictly increasing or strictly decreasing, it is open. The next interval is 2 to infinity. That's also open. Now how to find whether the function increasing or decreasing in this interval? So take a point from this interval. Any point, you can't take minus infinity and 2, any other point. So I can take this 0, I can take only after 0 only this 2. So I am taking 0 from this interval. So when x is equal to 0, what about f dash x? Substitute in f dash x. Where is f dash x? So when x is 0, is it positive or negative? The value is not important, just the sign. So when x is 0, minus 2. Minus 2 into 2 becomes minus 4. That is f dash x is less than 0. So less than 0 means strictly decreasing. Now from the next interval 2 to 3, I can take 3. So when x is equal to 3, substitute in f dash x. 2 into 3 minus 2. 3 minus 2 is 1. 1 into 2 is 2. That is f dash x is positive. So strictly increasing. Okay. So we can conclude after that. We can conclude therefore f of x is strictly increasing. Strictly increasing on 2 to infinity, and it is strictly decreasing. It is strictly decreasing on minus infinity to. Now the next question. It's a cubic polynomial like that. First we have to find the derivative. Find the derivative. 4x cube derivative is 4 into 3, that is 12x square, minus 6 into 2 is 12x, minus 72 into 1 and last term is 0. Again simplification, 12 is common, x square minus x minus 6. Can we factorize the bracket? Product is minus 6, sum is minus 1. So what are the numbers? Product minus 6, sum is minus 1. So 3 into 2, 3 into 2, 6. So minus 3 into 2. So we can write x minus 3 into x plus 2. Okay. So this is the simplified form. Now after this step, put f dash x equal to 0. That implies 12 into x minus 3 into x plus 2 is equal to 0, which implies 12 cannot be 0. So x minus 3 0 or x plus 2 0, which implies x is equal to 3 or x is equal to minus 2. Now draw the number line. The domain is set of real numbers. Draw the number line, infinity, minus infinity, infinity, 2, minus 2 and 3. Now you have to draw the table, interval, sign of f dash x, and next is nature of f. Column. How many intervals are there? When we have 2 points, we have 3 intervals. That is minus infinity, minus 2. That is one interval. Minus 2 to 3 is the other interval. Then 3 to infinity. Now minus infinity, minus 2. Take a point from that interval. Minus infinity, minus 2, I can take minus 3. So when x is equal to minus 3, what is f dash x? Find the value of f dash x. When x is minus 3, 12 is positive. X is minus 3, minus 3 minus 3 becomes negative. Minus 3 plus 2 becomes minus. So minus of minus becomes positive. Then second interval, take a number. You can take 0. So when x is 0, negative into positive, that is negative. Now from the last interval, you can take 4. 12 into 4 minus 3, positive. 4 plus 2 is also positive. So f dash x is positive. So first interval positive, negative, positive. Positive means greater than 0 means strictly increasing. Negative means strictly decreasing. And greater than 0 again, that is strictly increasing. So in the first interval it is increasing, second one decreasing, and 3 to infinity increase. So you can write the conclusion, therefore f of x is strictly increasing. Strictly increasing. 2 intervals are there. Strictly increasing on minus infinity, minus 2. Then you can put the symbol union 3 to infinity. Both the intervals it is increasing. And strictly decreasing on which interval? Minus 2 to 3. So we got the answer. 3 intervals we got. Which one increasing, which one decreasing, that we identified. Now one more question. F of x is equal to x plus 1 whole cube into x minus 3 whole cube. Same question, we have to find the intervals in which the function is strictly increasing and strictly decreasing. So we have to find the derivative. It is a product of 2 functions. We have to apply product rule. First function into derivative of second. Derivative of second means 3 into x minus 3 whole square into derivative of x minus 3, that is 1, plus x minus 3 whole cube into 3 into x plus 1 whole square into derivative of x plus 1, that is positive 1. Now common, 3 is common, x plus 1 whole square and x minus 3 whole square, this much is common. In the bracket we have x plus 1 and x minus 3. Again simplify that bracket. Here 2x minus 2. 2 is common, taking out 2, 2 into 3 becomes 6. X plus 1 whole square into x minus 3 whole square into x minus 1. That is f dash x. Now next step is f dash x is equal to 0. That means 6 into x plus 1 whole square into x minus 3 whole square into x minus 1 is equal to 0. Which implies each bracket equal to 0. 6 cannot be 0. So each factor put equal to 0. That is x plus 1 0 or x minus 3 0 or x minus 1 equal to 0. That implies x is equal to minus 1, x is equal to 3 and x is equal to 1. Now what is the domain of the function? It is all real numbers. So number line, mark the points minus 1, 1 and 3. Then draw the table, interval, sign of f dash x, then next column, nature of f. First interval is minus infinity minus 1, then minus 1, 1, then 1, 3, then 3 to infinity. Okay. Then you substitute, take a point from minus infinity minus 1, I can take minus 2. So when x is equal to minus 2, what about f dash x? F dash x is, look, 6 positive, x plus 1 whole square is always positive. It does not depending upon the sign of x. It is always a positive number. X minus 3 whole square, that is also a square, means positive. So you have to check only the last interval x minus 1. So put x is equal to minus 2. Minus 2 minus 1 is negative. So f dash x is negative. Now from the next interval, when x is equal to, next interval minus 1 to 1, I can take 0. Put x is equal to 0. So f dash x is negative. That also negative. Here I didn't write negative. That is also negative. Negative means strictly decreasing. And here also strictly decreasing. Now what about 1 to 3? 1 to 3 I can take 2. So when x is equal to 2, what is f dash x? When x is equal to 2, 2 minus 1. These two part you don't want to check. 2 minus 1 is positive. So it is greater than 0. And from the last interval, 3 to infinity, I can take 4. So when x is 4, then what is f dash x? 4 minus 1, that is also positive. So positive means strictly increasing. So what is the conclusion? Therefore, f of x is strictly increasing on 1, 3 union 3 to infinity. 3 is not included, only up to 3, then here after 3. Then f is strictly decreasing on minus infinity minus 1 union minus 1 to 1. If I put 3 closed, then it is greater than or equal will come. So, it is increasing, not strictly. So, this is the answer. I hope all of you understood this. Thank you.